So let's continue on. So we want to take this PDF of our S random variable and evaluate it at d1t over d2 and then times it by d1 over d2, and that will give us the PDF on the positive real line for our final F random variable that I've called t, confusingly. So I've written it down here, and I've written it in a form so that we can make easy comparison with our objective aim over here. So here is this square root here. So I've substituted in for s now d1t over d2. So we've got d1t over d2 to the power of d1 over, and then we've got 1 plus d1t over d2 to the power of d1 plus d2, and that's the square root. And then, as I say, I've brought these things onto the denominator under this square root so that it looks like this. So we've got over s, so I've substituted in d1t over d2 there, times then the beta thing is still the same, beta of d1 over 2, d2 over 2. And then, of course, we have to multiply the whole thing by d1 over d2, so that's what this is. So this should be now the PDF of my F-distributed random variable on the positive real line. And remember, on the negative and 0 numbers, it's just 0. So this is the only bit that's interesting. Now all we need to do is finally do a bit of cancellation. So you can immediately see that this d1 over d2 here cancels with the d1 over d2 here. Remember, of course, that we're using t here, but in the final formula here they're using x, but that's not too confusing. And then we just need to try and simplify this into this form here, and all we need to do that is multiply top and bottom of this denominator through by d2 to the power of d1 plus d2, I think, is going to be the correct thing to multiply through by, yes, and we'll do that in the next step. So as I say, this bit here and this bit here cancel immediately, so we just end up with t times our beta value here in the denominator, and then we've got the square root of this, and I've multiplied top and bottom by d2 to the power of d1 plus d2, so that doesn't change the fraction that I've got here. And the reason that I've done that is because that's going to be the thing that cancels. We can now see that this d2 to the power of d1 that's in the denominator in this numerator here is going to cancel with the d2 to the power of d1 here, so that we're just left with d2 to the power of d. Meanwhile, down here we can bring this d2 inside this fraction because they're both raised to the power of d1 plus d2, and then the d2 will cancel with this d2 on the bottom here, and you'll just get d2 plus d1t all to the power of d1 plus d2. So now if you make those cancellations, as I say, this d2 to the power of d1 here cancels with the d2 to the power of d1 here, so we just end up with d1 times t to the power of d1 times d2 to the power of d2, which is the bit of this that's left over. And then in the denominator of this thing in the square root, the d2 comes into this bracket because they're both to the power of d1 plus d2, and then cancels with that and multiplies by that, so you just get d2 plus d1t, all of that to the power of d1 plus d2, and then we've got that square rooted and then over t times beta of d1 over 2, d2 over 2. And then I've brought our objective down here to compare, and then you can see that if you just replace the t by x, all of this matches up. So if I replace this t by x here, you can see that the thing that I've got there is exactly the same as what we've got here. If I replace this t by an x here, okay, yes, they've written it as the other way around, but we've still got d1x plus d2 all to the power of d1 plus d2, the square root's there, and then just replace this t with an x here, and you've got x beta d1 over 2, d2 over 2. So we're done. We've derived the PDF of an F-distributed random variable with degrees of freedom d1, d2. And note, it's only non-zero on the positive real numbers. So this is the PDF for the positive real numbers. On the negative real numbers and at 0, it's just 0. So just a bit of notation then, we would write that this random variable t is F-distributed with degrees of freedom d1 and d2, and this is its PDF for little t is greater than 0, and it's 0 for the negative numbers and 0. We'll stop there. Thank you for watching.